Okay, geometry, ladies and gentlemen, this is 8.2. We're talking about the area of trapezoids, rhombi, which is just a plural of rhombus, and kites. So trapezoids, rhombi, and kites, that's what we're talking about, figuring out the area of those things. So let's kind of get right into it. This is a trapezoid. The reason I know it's a trapezoid is because two of the sides are parallel, and only two sides are parallel. So here's kind of the way I think about it. The way I think about it is I can kind of break up a trapezoid into making it look like a rectangle by basically, if I kind of sliced off this part and flipped it around here, I would make a rectangle. Okay, if I just put it over here, I would make a rectangle. Now, a rectangle we know is just base times height, or length times width, depending on how you look at it. So for trapezoid, kind of the logic becomes, well, how can I account for taking this over to here? Well, the way that I account for that is by basically saying I'm going to average this base and this base. Okay, so I've got the top base and the bottom base, or left and right, depending on which. Basically, my base is my two parallel sides. So I'm going to take the average of those, which is add them together, divide by 2, and multiply by the height. That's going to be how I figure out the trapezoid. Basically, what mathematicians did all so long ago when they had a shape like this was basically they said, okay, how can I take this difficult shape and put it into something simple like a rectangle or a square? So that's what they did. So they basically said, you know what, if I cut this in half and put it here, or if I cut this in half and put it here, that's going to be a rectangle or a square. Now my life is easy. So, so I've got a razor blade, 3 centimeters, 2.5 centimeters, 1. So that's going to be, these are my parallel sides. So, but I'm going to go 3 plus 2.5 divided by 2. 3 plus 2.5 divided by 2, because this is my base 1, base 2, times 1. So this becomes 2.75 times 1. So my area is going to be 2.75 centimeters squared. There's my answer. So now here, this is 30, this is 28, so this is 58. So right now my bases are going to be 28 and 58. Okay, so that's halfway there. 30 is not my height though. 30 is this length right here. So we'll assume that this is an isosceles trapezoid. Okay, we'll assume that these two are both equal. So 58 minus 28 is 30 divided by 2. So I'm going to make each one of these 15. So if I use Pythagorean theorem, because I actually use a right triangle here. So if I use Pythagorean theorem, that's 15. That's 30. Figure out what that guy is. That's going to be my height. Okay, so if I take 15 squared plus 30 squared, oh, sorry, wrong setup. 15 squared plus b squared equals 30 squared. So that's 225 plus b squared, that's going to equal 900. So 900 minus 225, so b squared equals 675. So b is going to be about 25.98. So I'll leave it at that. So the b in the triangle is this, but remember what this kind of represented. This represented my height. Okay, so this represented this number here. So multiplied by 25.98. So 28 plus 58 divided by 2 times 25.98. So that's going to be approximately 1,117. So there's my answer. So that's going to be in centimeters squared. Make sure you are including the label, otherwise we have no idea what you're talking about. So Kevin designed a deck shaped like the trapezoid below. Find the area of the deck. So it's a trapezoid. These are my two parallel sides. So if this is 4 feet, then if I draw a straight line here, that's also going to be 4 feet. But I got to figure out what this is. I know the whole thing is 9. I got to figure out what that is. Okay, that's not a 2. That's a question mark. So I want to take a look at this. So I've got another right triangle here. where this is 5, this is 4, right triangle. I got to figure out what that guy is. So I want to go Pythagorean theorem again. So I want to do that. Okay, so now I want to take 16 plus b squared equals 25. Hopefully by now you guys are getting pretty good with Pythagorean theorem. So b is going to equal 3. Okay, so this thing is no longer that. Now it's 3. So that makes this 6. So if I'm looking at solving this guy, what I got to do is take a look here. I've got 6 plus 9 divided by 2 times 4. So that's going to be 15 divided by 2. It's going to be 7.5 times 4, which I really hope is 30. So the area of this thing is going to be 30 feet squared. So now, you have silver earrings shown like this that are isosceles trapezoids. Isosceles means these two are equal, these two are parallel. What is the area of each earring? So, once again, it's isosceles, so if that's 3, that's 3. So that also means that if I drop the line straight down, those two are congruent. And that's kind of what I'm trying to figure out. So that's going to be 1, that's going to be 1, because this whole thing is 4. But if I cut it in each part, that's going to be 1 and 1. So that's going to be 2. So that's going to be plus 1, plus 1. So now if I've got a right triangle, that's 3, that's 1. So that's going to be 1 squared plus b squared equals 3 squared. All right. Hopefully this is nothing, none of you are, it's not breaking your brain at all. So you got b squared equals 8. So square root that guy. In this case, you actually do want a decimal. So the square root of 8 is going to be 2.828. So 2.83, that's fine. You can take 2.83. Think about context of the problem. So, how do I freeze that? So, when I go back to the problem here, I get 4, 2 divided by 2 times 2.83. It's kind of handy that it came with me like that. 2.83. So that's going to be 3 times 2.83. So 8.49 centimeters squared. That's going to be how big that is. So now, for a kite or rhombus, remember what's true about these is that the diagonals are perpendicular. Okay, the difference is that a kite, these two are congruent. Rhombus, all 4 are congruent. And kind of what I hope you notice when you look at this, I create 4 right triangles here, and I also do here. So kind of what you end up doing is kind of building off the area of a triangle and kind of expanding on that. So what you end up doing is this. You end up taking each diagonal, multiplying it and dividing it by 2. So you take diagonal 1, diagonal 2, and then multiply them and divide by 2. So that's what you end up doing for both of those. So if I look, find the area of the kite, real simple. This one's 8, this one's 15. 8 times 15 divided by 2. So I really hope you get 60 for an answer. So that's 60 meters squared. That's going to be my answer. For here, for 6, I'm going to assume that this is 12. Let's change colors so you can actually see it. This is 12. This is 10. So that means the whole thing across will be 20. This whole thing across will be 24. So I'm going to take 20 times 24 divided by 2. That's going to be 240 feet squared. So if you think about it, kind of the way you think about it, if you look at a kite or a rhombus, you know the diagonals are perpendicular, which creates a whole bunch of right triangles. And from right triangles, you're basically taking diagonal times diagonal. So you're taking base times height of the right triangles altogether. So if I take a look here, the area of the kite's 92, so we're kind of working backwards here. So you've got x times 22 divided by 2 equals 92. All right, so now, a couple different things I can do. I can either multiply both sides by 2 and get rid of this, or if you're moderately clever, you can realize, hey, 22 over 2 is just 11. So that means 11x equals 92. So divide by 11. And I'm going to get about 8.364. There's my answer. So that's approximately how big that diagonal is. Okay, let's take a look at the last piece. All right, find the area of the rhombus of RT is 24, so that's 24. RST is 54. Ooh, so this has got to be clever. So we're going to have to use a couple tools here. All right, first off, RT is 24. Sweet. So it splits. That makes that 12. That makes that 12. RST, this angle is 54. Diagonals bisect, so that means each one of these is going to be 27. So now I've got to figure out how big this thing is. Okay, so let's kind of look at what I've already built here. All right, so I've got a right triangle, which is going to be very helpful. That's a right triangle. That's 12. That's 27 degrees. I want to figure out what this is. Wow, if only I had something that could help me figure out what that is. Oh wait, I do. It's called trigonometry. So I have this one, this angle, I have this side, and I want this side. Okay, so it's not the hypotenuse, it's the opposite and the adjacent. So that means I want the tangent. So I want the tangent of 27 is going to be equal to 12 over whatever side that is. We'll call it B. So if you remember way back when to trig, basically all you do is these two switch places. So B will be equal to 12 over tangent of 27. So 12 divided by the tangent of 27, I get to be 23.55. Now, that's one of these. So double it. So that means the whole diagonal SU is going to be 47.1. So now I can figure out the area of this thing. So I'm going to take 47.1 times 24 divided by 2. So after all that noise, I get about 565.23. So there's my answer. Okay, I forget what it is, what's in. It's just, there's no label, so I just put units squared. There's my answer. Okay, so take some time with this. It kind of brings everything together. We start playing with all the pieces we've got. Come talk to me with questions.